Hello everyone, my name is Kamal Krishna and welcome back to the channel. In today's video, I am delving into Chapter 2 Computer Exercises from the book Introductory Econometrics by Jeffrey Wooldridge, and I am using Google Colab. It is a free online coding platform for Python, and the chapter name is Simple Regression Model. So let's get started. First, install all these necessary packages for this chapter. Pip install Wooldridge, pip install statsmodels, pip install matplotlib, and then import all these packages. Import Wooldridge as woo, import numpy as np, pandas as pd, matplotlib.pyplot as plt, and statsmodels.formula.api as smf. And then click on this play button, or you can type the shortcut Ctrl plus enter. So this is the first question. I'm going to make the mirror of this coded cell so that the output is shown on the right hand side and the code is shown on the left hand side. So in the first question, we are using the dataset 401k. Okay, so let's load the dataset. I'm using the data frame by the name of data 401k equals to woo.data in the bracket 401k, and then type the command print data 401k dot head to see the first few rows of the dataset. And on the right hand side, you can see the result of this command. These are the column names of this dataset: p rate, m rate, total part, etc. So this dataset is a dataset to study the relationship between participation in 401k pension plan and the generosity of the plan. The variable p rate is the percentage of eligible workers with an active account, and this is the variable we would like to explain. Therefore, this is the y variable. Okay, and the measure of generosity is the plan match rate, m rate. This variable gives the average amount the firm contributes to each worker's plan for each $1 contribution by the worker. For example, if m rate is 0.5, then a $1 contribution by the worker is matched by a 50-cent contribution by the firm. Now the first part of the question is find the average participation rate and the average match rate in the sample of plans, and then estimate the simple regression equation. P rate is being explained by m rate. So m rate is the x variable and p rate is the y variable, and we have to report the results along with the sample size and r squared. Then interpret the intercept in your equation and coefficient on m rate. Then find the predicted p rate when m rate is 3.5. and then explain, is this a reasonable prediction? And then how much of the variation in p rate is explained by m rate. So let's get started. First, we have to find the average p rate and average m rate in the dataset. So simply type the dataset name and then select this column p rate dot mean function, and for m rate select the dataset name, then the column m rate, then mean function. Now on the right hand side, you can see average participation rate is 87.36% and average match rate is 0.73. Now for regression equation, create an object by the name of model, or any name you like, equals to smf.ols in the bracket round bracket formula equals to p rate tilde m rate. It means that p rate is being explained by m rate. So p rate is the y variable, m rate is the x variable, and the dataset is data 401k dot fit function, and then print the model summary. So this is the result of OLS regression. You can see that our dependent variable is p rate, and the model has been estimated using OLS. And you can see the intercept here. Intercept is 83.07 and m rate is 5.86, and both intercept and m rate are significant in this equation. Now we have to extract coefficients. Type this variable name intercept equals to model dot params. It means that model parameters of the model, and in the square bracket for the intercept you have to type in the square bracket intercept, and remember to start this variable in the square bracket. with the capital I. Don't use small I, you have to use capital I in the square bracket. Okay, and for the slope, you can type model.params in the square bracket mrate. So look at the right hand side. Intercept is 83.08 as seen from above, and the coefficient on mrate is 5.86. Now we have to predict p rate when mrate is equal to 3.5. So type this mrate underscore value equals to 3.5. Then predicted p rate is intercept plus slope multiplied by this value, mrate underscore value. So look at the result. When mrate is equal to 3.5, p rate is equal to 103.59%. It is greater than 100%. So it cannot be possible practically. Okay, so it means that for any value around 3.5, the result will be 100% participation rate. Now look at this last part of the question. Compute R squared to measure explanatory power. When we printed the summary results of this model, R squared is also reported here. You can see that in the right hand side, R squared is 0.075, that is approximately 7.5%. To extract this value, we can use this method, type model dot R squared. So it will give you this value. And on the right hand side, you can see that R squared is 0.0747. And if it is greater than 0.5, then it means that mrate explains a significant proportion of the variation in period. However, it is less than 10%. So mrate does not explain much of the variation in period. Other factors may be important in the relationship. Okay, so we are done with this question. Let's move on to the next question. So in the next question number 2, we are using the dataset CEO Cell 2, and it contains information chief executive officers for US corporations. The variable salary is annual compensation in thousands of dollars, and CEO 10 is prior number of years as company CEO. So the first part of the question is find the average salary and average tenure in the sample. Then how many CEOs are in the first year as CEO, that is CEO equals to 0. What is the longest tenure as a CEO? Then in the last, estimate the simple regression model. Log salary, this log salary is being explained by CEO 10. So let's start. First, load the dataset CEO cell equals to woo.data CEO cell 2. Then display the first few rows of the dataset. Print CEO cell dot head, and you can see the columns in the dataset. Now we have to compute the average salary and average tenure. Create a variable average salary, average underscore salary, then type the dataset name, and then in the square bracket type salary column dot mean function, and for tenure type average underscore tenure equals to dataset name, then the data column CEO 10, then mean function. So average salary is 865.86. Okay, and average CEO tenure is 7.95 years. Now we have to count the number of CEOs in their first year and find the longest tenure. So create the variable num underscore first year CEOs, and then square under round bracket, select the dataset CEO cell, and then in the square bracket type CEO 10 equals to 0 dot sum. And for maximum tenure, create a variable max underscore tenure, dataset name, and then the column CEO 10, and then max function. So number of CEOs in their first year is 5, and longest tenure as a CEO is 37 years. Now we have to estimate the regression model where log salary is being explained by CEO tenure. So create a model by any name. I am using the model as model name. So model equals to smf.ols. Formula is, see in this column in the data set, you can see that salary column is also there, and the log of salary column is also there by the name of L salary. So we are going to use this column L salary tilde CEO 10, and the data set name is CEO cell dot fit. So now print the model summary results, model.summary. This will give us the regression results. You can see the intercept is 6.5 and the coefficient on CO10 is 0.009. It is a very small in magnitude, however, it is still positive. It indicates that the coefficient on CO10 is positively impacts log salary. Now we can extract coefficients from this model. For intercept, type intercept equals to model.params in the square bracket in the capital I and then intercept. And for slope, model.params in the square bracket type CEO10 and then print the coefficients. So coefficient on CO10 is 0.0097 and the intercept is 6.50. Now we have to write the interpretation of this coefficients. Interpretation: percentage increase in salary for 1 more year as CEO. So we can simply type, first create the variable %_increase equals to 100 multiplied by slope. So approximate percentage increase in salary per additional year as CEO is 0.97%. We are interpreting this variable in percentage terms because log has been used in the equation. Okay, you can if you do not understand the mathematics behind it, you can type in the comment your queries. I will explain this to you in comments. So this question is done. Let's move on to the next question. Now we are using the dataset sleep 75. So to study in the data set, it was studied whether there is a trade-off between the time spent sleeping per week, the time spent in paid work, and we could use either variable as independent variable. For concreteness, estimate the model sleep being explained by amount of work, that is total work. Okay, total work. So sleep is the y variable and total work is the x variable, where sleep is minutes spent sleeping at night per week and total work is total minutes worked during the week. Now it says report your results in equation form along with the number of observations and r squared. What does the intercept in this equation mean? If total work increases by 2 hours, by how much is sleep estimated to fall? So first load the data set, create a data frame sleep equals to woo.data in the bracket sleep 75. Then print the first few rows of the data set by using the command head, and you can see these are the column names in the data set. Now we have to estimate the regression model where sleep is the y variable and total work is the x variable. So type model equals to smf.ols, formula sleep tilde total work, and the dataset name is sleep.fit. Print the summary results of the model. In the model, the intercept is 3586 and the coefficient on total work is minus 0.15. It means that there is a negative relationship between total amounts, total minutes worked and the number of minutes spent sleeping per week. For concreteness, let's extract the coefficients. For intercept, type intercept equals to model.params and the square bracket intercept. And then for slope, type slope equals to model.params, type the variable name, that is total work. And for r squared, type model.r squared. And for number of observations, type length, len, len, and then in the round bracket, type the dataset name sleep. Now you can print the results. To see the sample size is 706, total number of observations in the data set is 706, and the r squared value is 0.10, that is approximately around 10%. And the regression equation is here as follows. So if total amount of work increases by 2 hours, and that is 120 minutes, we are converting hours into minutes because the data set originally is written in minutes, is written in the number of minutes. So how much does sleep decrease? So create a variable decrease underscore in underscore sleep and type the slope and type and multiply the slope by 120. Okay, so estimated decrease in sleep when work increases by 2 hours is minus 18.09 minutes. Okay, and when total work is equal to zero, so expected sleep per week is 3586 minutes. Okay, so we are done with this question. So let's move on to the next question. In the fourth question, we are using the dataset wage 2, and we have to estimate a simple regression where monthly salary is being explained in terms of IQ score. There are three parts of the question. It says, first, find the average salary and average IQ in the sample. What is the sample standard deviation of IQ? And then estimate a simple regression model where a 1 point increase in IQ changes wage by a constant dollar amount. It means that we have to take the log of wage to perform this. Okay, so use this model to find the predicted increase in wage for an increase in IQ of 15 points. Does IQ explain most of the variation in wage? Now it says, now estimate a model where each 1 point increase in IQ has the same percentage effect on wage. If IQ increases by 15 points, what is the approximate percentage in predicted wage? So now let's look at the solutions. First, load the dataset by typing the dataset name wage equals to woo.data in the round bracket, type wage 2, and then display the first few rows of the dataset by typing print wage.head command, and you can see these are the column names in the dataset. Now to calculate mean of wage, simply type the column name wage and then use the method mean, and for mean IQ, select the column IQ and then type mean function, and for standard deviation of IQ, type the column name IQ and use this standard deviation function std. So average monthly wage is $957 and average IQ is 101.28 and standard deviation of IQ is 15.05. Now estimate the simple regression model where wage is being explained by IQ. So type the model's name, model equals to smf.ols. Formula is wage tilde IQ. It means that wage is the y variable, IQ is the x variable, and then type the dataset name, data equals to wage, and then dot fit function. To see the regression results, type print model.summary, then extract the coefficients. For intercept, type model.params in the square bracket intercept. For slope, type model.params in the square bracket IQ, and for r squared, model.r squared. So this is the estimated equation. On the right hand side, you can see the intercept is 116.99 plus the coefficient on IQ is 8.3031 and the r squared is 0.0955. It is less than 0.1. That means it explains less than 10% of the variation in wage. Now it says compute predicted wage increase for a 15-point increase in IQ. So create a variable wage underscore increase underscore 15 equals to slope multiplied by 15. So predicted, in the right hand side you can see the predicted increase in wage for 15 IQ points is $124. So if IQ increases by 15 points, there will be increase in wage by $124. In this print command, you can see I am using this curly bracket within the print command so that the string data type and variable data type can be written together. Okay, this print f is f string literal and then quotation marks, and this curly bracket is being used to integrate the variable in the string data type, and this 4f, it means that I want the value to be shown up to 4 decimal points. That's why here it is showing in the equation, it is showing the values up to 4 decimal points. So let's move on forward. Now we have to estimate the log linear model. That is, we have to take log of wage and everything else remains the same. For this, we can create a new column in the wage dataset by taking the log of wage. So first type the dataset name, and then in the square bracket type log wage. We will call this new column by the name of log underscore wage equals to np.log, and then in the round bracket type the dataset name wage, and then the square bracket select this column wage because we want to take the log of this column wage. So a new column has been added to a dataset by the name of log underscore wage. So now we will estimate the regression model where we will take the log of wage. Type the new model's name by the name of log underscore model equals to smf.ols, and in the formula log wage log underscore wage tilde iq, and then data equals to wage, and then dot fit function. Now print the regression results by typing print the model's name log underscore model dot summary. Now you can see that the intercept here is 5.88 in the log model, and the coefficient on IQ is 0.0088. Now extract the coefficient from log model by creating the variable log underscore slope equals to log underscore model dot params. In the square bracket type the column name IQ. Now we have to compute the approximate percentage change in wage for a 15-point IQ increase. So again, create a new variable by typing percent underscore change underscore 15, and we have to multiply this log underscore slope by 15 in 200 because we are looking at the percentage change. So predicted percentage increase in wage for 15 IQ points is 13.21%. Okay, so we are done with this question. Let's move on to the next question. Thanks for watching. If you found this helpful, don't forget to like the video and subscribe to the channel for more content like this. See you in the next one.